Good afternoon and welcome to the Asia Clean Energy Forum Thematic Track 2, Session 2.2. My name is Cindy Cisneros Tiangco, Principal Energy Specialist, AD Pacific Department, and I am your session moderator. ASAP Track 2 focuses on innovative low-carbon technologies and emerging new technologies that are shaping the energy transition. Session 2.2 in particular will focus on circular economy, which is defined in a nutshell as maintaining the value of products, materials, and resources in the economy for as long as possible and minimizing waste. While some technologies and approaches similar to or applying the circular economy concept have been around for some time, large-scale deployment and application of these technologies across value chains and industries are taking a while to be mainstreamed. In addition, some new and emerging technologies have yet to obtain optimal and commercial applicability. So continuous innovations are needed as energy systems evolve and energy transitions to a low carbon and climate resilient pathway. For this session today, we have two presenters and four panelists to provide their insights into promoting a circular economy within the energy transition. Speakers and panelists in this session will cover a range of circular economy approaches, including for renewable energy equipment, the fashion value chain, and battery reuse and refabrication. The session will also include discussion of decarbonization of heavy industry and an ADB tool for planning waste management systems and analyzing their environmental, economic, and social performance. Our first speaker, Ms. Monica Simarmata, Energy Sector Associate of Tetra Tech, will present how a circular economy is creating sustainable businesses and local jobs in recycling, repair, and rental services, as well as cultivating economic opportunities throughout Asia, including for women. So over to you, Monica.
Thank you, Cindy. Hi, everybody. Good afternoon. Happy Wednesday from Washington, D.C. My name is Monica, and I am an Energy Sector Associate at Tetra Tech, and I manage USAID's Scaling Up Renewable Energy, or SURE program's workstream on circular economy. I'd like to thank the organizers of the Asia Clean Energy Forum for this wonderful opportunity. Today, I'll be talking about circular economy, a new business model to power development. To give you a little context about my work, USAID's Scaling Up Renewable Energy, or SURE, is a $29.7 million 5-year program implemented by Tetra Tech and its partners. This program helps partner countries meet bold international climate commitments by increasing adoption of renewable energy technologies all around the world. Through its circular economy workstream, we work with partners to develop new innovations, sustainable practices, business models, and secondary markets for parts and materials of renewable energy equipment. A little bit about Tetra Tech. Tetra Tech is a global engineering and consulting firm with more than 40 years of experience for key energy projects in over 100 countries. So, the global energy industry is making strides to reduce carbon dioxide emissions to net zero by 2050. But the demand for more solar PV panels, wind turbines, and batteries is creating pressure on the environment, from increased mining of critical metals for clean energy technologies to the growing piles of waste that accumulate at the end of the equipment's end of life. So the question arises, are renewables actually as clean as we think they are? What you see on the left is a municipal landfill in Casper, Wyoming. It's a final resting place of about 870 wind blades. Did you know that a wind blade can be as long as a Boeing 747 wing? By 2023, Wind Europe estimates 14,000 blades could be decommissioned, equivalent to 50,000 tons. The picture on the right is a picture of a shredded electric vehicle battery. And by 2030, Bloomberg estimates a whopping 2 million metric tons of lithium-ion battery scrap per year. So from these two pictures, you can imagine the scale and magnitude of this growing problem. As the world weans off fossil fuels towards a clean energy future, we are also piling waste and mining resources at a massive scale, using practices that can result in environmental destruction and social justice issues like forced labor. So how did we get here? The world we know today is a product of the linear economy, a term used to describe the take-waste scheme that the man-made world today has operated on for decades. A circular economy is an alternative to the traditional linear economy in which resources are kept and used for as long as possible, Maximum value is extracted from them while in use, and materials are recovered and products are regenerated at the end of each life. So in the renewable energy equipment context, there has been innovations in recycling that have the potential to recover critical metals and other materials to keep them in use as long as possible, reducing the need for virgin materials. Alternatively, used components with minor damage can be repaired and refurbished, opening an opportunity to expand electronics repair and maintenance markets to include renewable energy equipment. So as you can see here, circular economy does not equal recycling. Recycle is only one component of it. So that sounds like a really cool concept, but why should we care and why should we take this very seriously? So here I present to you the reasons to make the case for circular economy. First is to tackle the climate crisis. According to the IEA, completely transforming how we produce, transport, and consume energy is imperative to reduce global CO2 emissions to net zero by 2050. Circular economy can also generate jobs. According to the International Labour Organization, a circular economy could create a net increase of 6 million jobs by 2030. New business models focused on reusing, repairing, and services like rental and remanufacturing can share significant innovation opportunities. And there will also be new enterprises that spring up to make innovative use of secondary materials. A circular economy can also support a just and inclusive transition. A gender inclusive approach to circular economy means that women and men have the same access to political, economic, and social opportunities offered by the sector today and tomorrow. And a key term and a buzzword that we hear a lot in media is that the annual need for critical metals could endanger the transition to a clean energy economy. Mining these and other resources can contaminate waste, contribute to biodiversity loss, and can also involve frequent human rights abuses. And last but not least, circular economy can activate local partners. It involves multiple sectors and also actors in the local value chain, such as renewable energy equipment suppliers and retailers, owners and operators, transporters, and maintenance and repair businesses. So zooming into Asia. So the SURE program worked on an opportunities assessment, and our findings indicate that application of the circular economy framework to renewable energy is still in its early stages. The first example that I want to bring to you is First Solar. First Solar is a unique example because of its existing and upcoming presence in Asia. It's a pioneer in PV recycling, both in terms of technology and having a recycling program for customers to opt into, and the application of eco-labels. In Asia, First Solar operates PV manufacturing factories and commercial recycling facilities in Vietnam and Malaysia. It's also building a new 3.3 gigawatt factory in India with $500 million of debt financing from the DFC. First Solar's advanced high-value recycling program can recover about 90% of materials. It is also the producer of the world's PV product to be rated in the Electronic Products Environmental Assessment Tool, or EP registry for sustainable electronics. EP is a useful tool or an eco-label that can be used by governments and private sector purchases as part of their sustainable procurement decisions. It can also provide customers confidence that they are purchasing an environmental leading product from a socially responsible company. Another exciting example in Asia is the Solar Waste Action Plan pilot funded by the Netherlands-based Signify Foundation and Doing Foundation. It aims to develop solutions for better management of end-of-life solar-based product waste. The SWAP team looked to establish a pilot PV recycling facility with a processing capacity of 2.5 tons per day. This project motivates local employment generation and contributes to establishing a formal solar waste treatment sector in India, compared to the other waste stream sectors that are highly unorganized. Another example in Asia is in the Philippines. A United Nations Industrial Development Organization project provided a new facility and safety training for female and male recyclers. The existing municipal waste facility in Bagong Silang was upgraded into an e-waste treatment, storage, and disposal facility. In addition, the workers were also supported to obtain required license and formalize their employment with the municipality, thereby enabling them to increase their income. So we talked about the what and the why. Now we talk about the how. How can we harness a circular economy to power development? In the middle, you see here a picture of camera lens having a clear picture of when it zooms in and a blurred picture when it zooms out. The core of circular economy is systems thinking, or the ability to see the big picture and understand how interconnected systems are, just like how it is in nature. So this is a call to action to apply a circular economy lens in our work, starting from capacity building to increase awareness of the problem and potential solutions that a circular economy can bring. We then can understand the local context by assessing country-level opportunities. An enabling environment that goes hand in hand with private sector initiatives can spur progress. Our findings from SURE's opportunities assessment indicate that without larger scale policy interventions, private sector participation is often product specific, contextual, and in different parts of the value chain. Pilot projects are a powerful tool that can stimulate innovations and help set up a marketplace for buyers and sellers of second life renewable energy equipment, and lower the cost of harvesting and collection. And last, and of course not least, a gender inclusive approach to circular economy is essential. So to ensure that everyone has the same access to the opportunities that a circular economy can bring. So as you embark on your journey to reshape the energy ecosystem to become more circular, here are some resources that the SURE program has developed that can be accessed on usa.gov and the Circular Economy page on Climate Links. As I have mentioned, SURE developed an opportunities assessment. We have the opportunity to engage multiple stakeholders on a global level to generate findings to make a compelling case for a circular economy and present current industry practices and opportunities in this nascent pace. Another thing I'd like to mention is SURE is moving very quickly toward implementation, particularly in the form of pilot projects in USAID partner countries. SURE seeks collaborators to partner or co-invest in pilots that cultivate new business models, innovations, initiatives, sustainable practices, policies, and markets. So to end my presentation, here's a quote from the famous Albert Einstein: "We can't solve problems by using the same kind of thinking we used when we created them." So thank you so much, and I hope you gain valuable insights from this session.
Thank you so much, Monica. It's a very interesting presentation, and you've given a very nice overview for the entire session. If I may ask, based on your research, what is a current level of uptake compared to the opportunities available when it comes to circular economy approaches?
Thanks, Cindy. So our research focused on the 3 renewable energy technologies: solar, wind, and batteries. And it is all over the map. So for example, in solar, we see a lot of movement in, let's say, recycling, but from the people that we talk to that are actually engaged in the business operations, there seems to be a gap in harvesting and collection. Another example, in the wind technology, we see private sector partnerships in terms of recycling. For example, one company that we spoke to indicated that wind turbines are fed into cement producing companies. So as I had mentioned, that it's all over the map, it's segmented, and it's very product specific. And there needs to be a larger scale policy push to integrate and to enable this environment, so it creates the right market signals for private sector to participate.
Thank you. I will ask some more follow-up questions about in the panel discussion. Thank you very much. We can move on to the next speaker. We have a recorded presentation from our second speaker, Mr. Peter Warren, Team Leader for Climate Innovation, Department for Business, Energy and Industrial Strategy of the United Kingdom. Peter will present the importance of decarbonization and circular economy in heavy industries, and will highlight some case studies.
Afternoon, good evening, everyone. Welcome to the Asian Clean Energy Forum and to this session on circular economy and its importance in the decarbonisation of the energy sector. It's great to be back at the Asian Clean Energy Forum again. Last year we ran a deep dive workshop specifically on the topic that I'm going to speak to today. But in this presentation, I want to speak more about how decarbonisation of heavy industry fits into this wider discussion on energy sector decarbonisation and so the role of circular economy as well within that. So just to introduce myself, I'm Peter Warren. I lead our climate innovation work in our international climate finance part of the UK government's Department of Business, Energy, Industrial Strategy, where we focus a lot on how do you accelerate the commercialization of clean energy technologies in aid eligible countries. But just to quickly start off with a bit of context of why we're focusing on heavy industry, it does make up a huge amount of emissions and total energy final consumption. So it is what we call a hard to abate sector, a challenging one, but a really important one to look at. And we've really been trying to look at what's the role of technology innovation and business model innovation to really facilitate decarbonisation around the world. In Asia Pacific, there's a large demand, an increasing demand for materials and goods, and this is a trend all over the world. And so what we're looking at is how can we look at how do you apply some of these new ideas, new concepts in practice, what the opportunities, what are some of the challenges, how do we overcome some of those challenges to really look at how do you decarbonise a set of important hard to abate sectors. So in some of the work that I'm going to discuss a bit later, we'll look at the role of innovative tech, but also where we've supported some circular economy approaches and also the importance of doing deep energy efficiency as well, but also going beyond energy efficiency to look at how do you get to use things like fuel switching approaches or those technologies that can look at new ways of providing the energy. There's been some really important analysis that's come out over the last few years about why it's still important to support innovation. So we need to support the scaling and replication of existing technologies, but we also need to support so technologies that are not quite at the market readiness stage. So the IEA estimates that about 35% of emissions reduction still needs to come from technologies that are currently not fully commercialized yet, and they're at earlier stages of development, such as the prototype or demonstration phases. So how can we not only support these technologies, but how do we accelerate bringing them to market, as well as building the markets themselves? So it takes about 10 to 30 years on average for a new technology to go from prototype stage to commercialization. So what's the role, for example, of international initiatives and international climate finance to really help support this in the Asia Pacific region? I briefly just wanted to cover a few things the UK is doing itself, in case that's of interest, on trying to decarbonize heavy industries. So we set a 78% emissions cut by 2035 in our sixth carbon budget. So this is across the sectors, across society, and this led to our 2050 net zero strategy about how to do that across different sectors. And we followed this with a set of sector specific strategies, such as an industrial decarbonisation strategy just over a year ago, and a hydrogen strategy, which included actions on hydrogen in heavy industries. There are very active CCUS policies. Most recently, we brought out an investor roadmap. But our CCUS program currently is trying to aim to develop and deploy 2 industrial CCUS clusters by the mid-2020s and 4 by 2030. And my colleague from our CCUS domestic policy team has presented in the Asian Clean Energy Forum this week on what we're doing on CCUS. So if people are interested, please do go to the CCUS deep dive workshop and if you want to hear more. There's also an important role for innovation funding and sort of competitions. So we've got a number of competitions we set up, such as a net zero hydrogen fund for hydrogen projects, which includes industry applications, £170 million industrial decarbonisation challenge fund, and then various innovation funds for CCUS and infrastructure funds as well. And as I said, you can hear more about those in more detail in the CCRS workshop. There's been a growing amount of international actions and initiatives on this topic. So there's been a growing attention over the last couple of years, such as through the work of the second phase of mission innovation, through the launch of the Glasgow breakthroughs at COP26, and we launched the hydrogen steel breakthroughs as well as part of that. The UK played an important role in developing the industrial decarbonisation agenda under our G7 presidency last year, and we've been trying to shape proactively the industrial decarbonisation initiative under the Clean Energy Ministerial to really look at how do we decarbonise, for example, steel and really push forward on topics like green steel. But I wanted to cover as well a bit more on international climate finance. So the UK doubled its international climate finance to 11.6 billion out to 2025 to 2026. And our international climate finance comes from our aid budget, so our official development assistance budget, but with a specific focus on supporting aid eligible countries to mitigate and adapt to climate change. Under this, we set up an industrial decarbonisation innovation fund, which comes under a broader facility called the Clean Energy Innovation Facility, which the Asian Development Bank partly delivers. But the industry fund specifically, we've partnered with the World Bank to look at how to provide grant funding to innovators that are looking at how to accelerate the commercialization of technologies that could be applied to heavy industry. So this includes circular economy approaches and resource efficiency approaches, includes decarbonisation approaches such as CCUS, or piloting fuel switching to renewables. And we have an annual review that we publish every year, and I've included a link there to the latest one. We've actually got our latest annual review is coming out very, very shortly, the 2022 one, so I'll make sure that I circulate that if that's of interest. It talks about how we measure impacts, the success, but also the challenges and the lessons learned to then sort of improve the next round of support. So I just wanted to end my presentation with a few case studies from that Industrial Decarbonisation Innovation Fund that I just mentioned, of some really exciting projects that are taking place in the Asia region. So firstly, one of the projects is supporting Bangladesh to look at how renewable energy can be expanded within the development of green economic zones for use in heavy industries. This is a project started a couple of years ago, and it's ongoing at the moment. So the sort of funding that we provided looked at supporting technical and financial assessments, pre-feasibility studies, and support during the implementation phase. So some of the early outputs to date are the completion of studies on material recovery and looking at how to implement floating solar in particular around those zones. But also the importance of creating that enabling environment and supporting the development of regulation as well. The second case study in Kazakhstan looked at supporting clean energy transitions through the Industrial Energy Transition Initiative, and it's another ongoing project. Really looked to focus on identifying what might be some key relevant technologies in the context, but also not just the technical side, but also that, again, as like in Bangladesh, is really important to look at how do you foster that enabling policy and regulatory environment when looking at heavy industry decarbonisation. So some early outputs to date include sort of some recommendations on how to sort of implement to build that policy and regulatory environment, and specific technologies as well. So technologies and measures for 5 early adopter enterprises have been identified. And my final slide, in Turkey, we looked at promoting low carbon technologies in organised industrial zones. And this did focused a bit more on the capacity building and training side, as well as similarly to the other two projects, providing those technical and financial analyses. It also looked at how to develop a certification system, as well as doing pre-feasibility studies in a pilot model factories. So some early outputs to date. 2 business cases were developed, certification systems being proposed, and pre-feasibility studies of a pilot project have been completed. So I've hit my my allotted time slot, so I'll have to end there, but I'm really looking forward to following up and listening to the other speakers, and apologies that I couldn't be there live today, but I hope to follow up with everyone over the coming days and weeks. So thank you very much.
Thank you very much, Peter. That was a very interesting presentation. And this goes to show really the significant potential for decarbonization in heavy industries. Kazakhstan, for example, you have 70% of emissions or energy consumption comes from only 15 heavy industries. So that's how deep the potential is for a circular economy in the heavy industries for Kazakhstan in particular. So let's now move over to our panel. Joining Monica on the panel are our 4 panelists, Kajol K, Senior Manager from the World Resources Institute, India. We have Dr. Yu-Tak Kim, Division Director, Korea Battery and Industry Association, and Pia Kurdia, Managing Director of PXP Sustainability. And we had hoped to have Mr. Elias Tao, Chief Technical Officer of Warenco, to join us, and hopefully he can still join us within the next few minutes. But my first question goes to the first 2 speakers, Kajol and Yu-Tak. Could you please describe your industry and how the circular economy concept is applied there? And could you please give us some specific examples?
Sure, thanks. Thank you, Sydney, for giving us this opportunity to discuss our learnings on the demand aggregation work that we have done in the fashion industry. So my, the answers will also be pertaining towards the fashion industry and the work that we have done there. So, producing the clothes require a huge amount of water, especially like when from the beginning, from the cradle to the grave, there is huge amount of the water consumption. And at the same time, the energy to power the spinning and the manufacturing processes. Even the chemical consumption for the fertilizer usage to the dry of the textiles are quite high. So our focus was largely to look at like how these fashion industry can work towards the usage of a better energy efficiency and water management. And we know that at the same time, the global industry is coming forward and pledged to become carbon neutral by 2050 and half its emissions by 2030. So in India, we worked with the leading fashion industries where we visited some of their supply chains, and here in India, spread across different provinces and states in India. We looked at their current energy consumption to develop the baseline and see how much is the overall GHG emissions around that. And what would be the related GHG emissions reduction based on the clean energy assessment study and GHG emission reduction study we did. So based on the data that we collected and in concurrence with the walkthrough assessment study we did, we found that there is a significant gap in the clean energy measures and the water management. Although some of these suppliers are quite proactive in adopting and implementing low-hanging energy efficiency measures, and some of the larger suppliers have also implemented the solar plants, or they are going forward towards the renewable energy. But there is a huge gap in terms of the adoption of a large scale and scaling up of these, specifically the clean energy measures. Although, when we talk about the fashion industries, they are quite well organized in terms of as they follow the Higg Index. But there are always like these challenges on the data, which was like when we work with the small industries, that becomes one of the most prominent issue. So some of the findings that I can, summarize were, when we look at the usage of the fossil fuel, the coal is commonly one of the main fuel that has been used in the textile industries in the mills, and moving towards the transition is a little difficult. So they currently prefer the coal as there for the thermal energy, and looking for the water heating and for the steam purposes. So they have been now looking to move towards the biobriquettes, which are sustainably procured, or even utilization of the renewable energy to power some of these processes, and better insulation on the steam line. So these were a few of the examples that we came across. And when we look at the overall energy transition, we looked at the shift towards the renewable power, pivoting the how we can move away from the fossil fuel, and at the same time the better water management, utilization, use of the process heat, which was currently not most of the industries are using that process heat again to be reheating the input water and the fuel, and that can be utilized with a simple modification into the system. And that is how the focus was more onto that. And there comes to be a huge potential overall when we look at the circular economy concept as well, like reusing the heat and reusing the water, and also at the same time reducing the overall GHG emission. Yeah.
Thanks, Kajol. And those are just a comprehensive list of solutions that you provided there. And what sort of potential are you looking at for, say, self-generation using renewables or using waste heat in the textile industry?
So assuming that we are looking at the full phase out of the coal, especially in the thermal energy production and the tier 1 and tier 2 of these suppliers, we estimated that there will be about like a 13% reduction of the CO2 emission. And our recommendations to the stakeholders were largely based upon like how this large amount of thermal energy, either in form of hot gases or the exhaust that is coming out, or the hot liquid that can be utilized again into the systems, instead of throwing them out into the atmosphere, but can be coming from the various processes and can be reused. Especially when we look at the Indian textile mills, a lot of work has been done to recover the high grade heat, but the low grade heat has always been like an ignored factor. And when we look at that, around 30 to 40% of the total energy which is wasted in form of the low grade heat can be utilized well for inside into the process as a hot water, or we call that as a waste, but I would say like that's the main, it can't be called as a waste. It's more like, something that you need to be utilizing again, and that helps you further to look at it. So the waste heat recovery system, the reheating of the system, and during our assessment also, we looked at some of these waste heat recovery system and how this can be better utilized. There were few case studies coming from not just from the textile industries, from the other industries. The large industries, in case of the cement, they are already using a lot of the waste heat and they reheat the clinical processes. And by the end of that, the most attractive thing is the payback period. So when we calculate the overall payback period for the utilization of this heat and reducing their fossil fuel consumption and improving upon the overall efficiency of the system, the payback is for most of these industries was less than 1 year, which is a very good proposition to look at, because the industries have to put very little of their investment to do when the payback is quite attractive in that case.
Thank you. You touched upon my second question for the next round. Let me go to you, Tak. How is it applied, circular economy? How is it applied in your industry? And how do you see it changing the economics of batteries, for example?
Yes, good afternoon. Can I show some infographics? Can you show this one? Yeah, sure. Actually, we were considering to the second life of batteries, the key technology to reduction of carbon dioxide. Actually, our circular economics, we need to do some reduction of carbon dioxide generation. During the production, we must need the carbon dioxide, but end-of-life batteries can be possible to use another application. In case of the EV cars, we use for high performance battery in EV cars, but rest of the another application like energy storage system, in mobility, still right, these ships, they just need some less of the high performance batteries. So it can be possible to the second life, end of life using the EV cars. And finally, we are getting to some recycling to get some precious materials like the lithium and cobalt nickels. Basically, these reuse republication industry can be reduction the cost of the new battery manufacturing cost. Also, it does not care about the carbon dioxide generations. Also, in Korea government, we are worried about all of the cars to replace to the EV car, and then EV cars battery can out of the life after 5 or 10 years. It will be the waste after end of the life the EV car batteries. So we need to do some social problem to how we can recycling or reuse to our EV car batteries. Maybe it is all in advanced countries have the same problem, the EV car batteries. And so we are thinking to the EV car battery can be used for another various kind of application like the golf cart, wheelchairs, scooters, personal robot, and energy storage system. Also, we need some technology to how we can evaluation graduate the battery system. So it needs to some high technology to critical estimation technology to evaluate the battery system about the reuse, republication, and recycling. And also our battery manufacturers, they are big hurdles to how they can reduction the carbon dioxide during the life cycle assessment of the battery system. So battery system can produce to the carbon dioxide during to the productions. So, but after end of the life battery can be reduction to the carbon dioxide using to the second life and that means the reuse and republication. This is our issues to battery can be help to the carbon dioxide generation reductions. Yeah, thank you.
Thank you very much, Yuta. Could you expound on the financial and environmental benefits of reusing and refabricating these batteries? Monica earlier showed a photo or indication of how lithium-ion waste batteries are becoming an issue. Could you expound on that, please?
Actually, we also have some problem about how we can reduction the waste. Also, how we can get manufacturing the precious metals, but waste can be separated into the landfilling or recycling materials. So our Korea government and our battery manufacturers, we have to get all of 100% of the recycling during the for the end of the life batteries that can be get precious metals, and then we have to reduction to the landfilling. Actually, just left right can be possible to the landfilling. Other materials can use for the new materials for the new batteries. So, but basically, the recycling process is still the problem to make some environmental problems, like to generate higher carbon dioxide generation by to some furnishers and other chemical reactions. So we are thinking about how we can reduction to the environmental impact to reduce the chemical materials. So right now we are doing some directly recycling can be help to the some environmental problems during to the recycling. So also Korea government have to another new government supporting R&D project to use the water-based recycling technology. It can be possible to solve the environmental problems during to the recycling. Yeah.
Thank you very much. Yeah, that's a very good point, because while you are reducing waste, you are also creating waste in the process. So that also needs to be managed. I think we can go for another round later. Before that, I'd like to call on Pia Kirdiap to show us the circular economy planning tool that he developed with ADB. Over to you, Pia.
Sure, thanks, Cindy. So just a bit of background of myself. I work at PhD Sustainability, and we support companies, nonprofits, and development agencies in measuring and strategizing their sustainability goals. And another hat I also had the opportunity to wear was a circular economy modeling consultant for the Asian Development Bank. And we worked together to develop a Excel-based tool for planning different types of waste management systems and also measuring their environmental, economic, and social performance. And one of the reasons we developed this tool is because waste management planning is very complex, starting off with just the mix of waste that comes out from a city, whether it's municipal solid waste or industrial waste. And then there's a variety of different technologies and business models that can be used to manage the different waste streams. And so because of this so complex, it can take a long time for governments to actually plan such systems. And it might be, the default option might just be to do a large waste energy incinerator, when there's actually a lot more options for dealing with waste and capturing as many resources as possible. So rather than me just talking about this tool, I'll just play a brief video that explains how it works.
This is the homepage of the ADB Waste Analytical Resource Planning Scenarios tool. To design a waste management system and analyze it, there are 5 steps. Step 1, create a waste profile by setting the amount of waste generated per day and its percent composition. Step 2, design the system by selecting processes to deal with the different types of waste streams, such as sorting, recycling, energy recovery, and final disposal. Step 3, establish the local context by setting values for parameters across a wide range of categories, such as taxes, sale value of resources, social benefits, and carbon credits. Step 4, view the results at a high level. You can also view the results at the system level and processes. Step 5. Create a Sankey diagram by clicking on the button in the Results tab. This diagram shows the waste flows and how they are managed in the system. Page of the ADB Waste Analytical Resource Planning.
So that's pretty much how the tool works. Right now, it's a beta product that's still doing some more testing. We have the opportunity to do a case study with it in a city in Indonesia. And the government officials there really liked how rapidly you could do such an assessment and measure the environmental impacts, such as greenhouse gas emissions, emissions of NOx and SOx gases, and also looking at the financial performance in terms of how much subsidies would be required if you were to implement sorting recycling with biogas versus just implementing one giant waste to energy facility. And in terms of like what type of applications this tool is useful for, the way I think of it is that it's not meant to replace a full feasibility study. Rather, it's meant to do accurate calculations to just explore what are the options available and to get a conversation started about what are the different ways we can manage our waste and how complex can it be and how can we manage it. A quick analogy would be if this tool is almost like a ATK rapid test. It's quick and easy to do, and you'll get pretty accurate results. But if you want to guarantee, you want to do a final investment, you probably want to do a PCR test to get something very accurate. That's just the tool in summary.
Thanks so much, Pia. Very interesting. So this has been rolled out. Do you have some like initial findings that the usefulness of this tool from case studies?
Sure, I can tell you more about the Indonesian case study. So what we did was in Indonesia, the city we looked at, the central government had considered implementing a waste to energy facility in the city. And one of the concerns was how much of investment would be required, how much subsidies would be required to keep this waste to energy facility operating. And the Ministry of Finance, which we worked with in also developing the tool and running the case study, they were interested to see if there are other options instead of just doing a giant waste to energy facility. And so what we did was we took some of the data they had about their waste management system, and we looked at their baseline scenario, which is just sending everything to a landfill, or what they call the TPA. And from that case study, we also looked at three groups of scenarios. We had one giant waste energy facility, and then we had sorting and recycling with anaerobic digestion. So the anaerobic digester would capture all the organic waste that is separated out from the sorting facilities and turn it into electricity that could be used. And then we also consider other factors like carbon pricing and such. And what we found from the study was that if you implement sorting and recycling, you'll have less direct emissions of greenhouse gases and other air pollutants, and also bring more jobs, because sorting and recycling, they can offer more jobs for both men and women, and also have less impact to the subsidy requirements from the central government. And so just a general find, we also found that once you increase the complexity of the systems, you get more benefits, and you can reach out to different types of stakeholders and get more people in the circle.
Yeah, interesting. Could you give us a sense of the users who benefit from this, or who can access this tool?
So right now, the tool is mainly used by ADB to interact with the governments. There are plans being discussed on whether this will be rolled out as a public tool, but right now, since it's in beta, we're still trying to work on improving some of the different aspects, such as the visualization, increasing the amount of data for different processes we want to model, incorporating factors such as black soldier flies that can convert food waste into alternative proteins. There's just a really wide range of different processes you can use to convert different waste into resources, and not just energy, but actual physical resources. And so that's where future development is going on before a decision is made about whether to roll it out and make it publicly available.
Thanks, because this certainly is going to be useful for governments in terms of planning, for particularly for infrastructure projects.
Yeah.
We always use the concept of life cycle or cradle to grave, because there's a lot of opportunities for circular economy concepts to be applied across the value chain, across the life cycle of each and every project or technology or system that we install or implement. So we look forward, of course, to having that available more widely, and I'm sure a lot of users will be happy to be able to use that for their purposes. So let me go to the next round of questions. I just wanted to talk or ask all the speakers about their vision of how circular economy you think could be applied more widely. Is there scaling up from the industries that you are looking at, and how far could this go in terms of uptake and ownership? Maybe we can ask Monica first on some of the case studies that you've looked at.
Sure, that's an interesting question, Cindy. So I think an interesting example would be in the wind industry. We see there is an existing consortium in Europe, and it's quite interesting because it spans through multiple stakeholders. It's not just the energy sector, it involves the waste sector as well. It involves strong R&D, and seeing this strong collaboration, it looks like that will be a fertile ground for this to be replicated across industry. So the keyword here is a collaboration, and defining very clear what sector is responsible for what, and whose liability and responsibility is it to handle these end of use equipment. So I'm quite excited to see that replicated across multiple industries. For example, we see also in the US solar industry, the industry association drives the collaboration between recyclers and the solar industry. So recyclers that don't know how to recycle solar panels are educated by the players in the solar industry and vice versa. Cross education and cross collaboration is a key puzzle piece here.
That's a very good point. Very interesting. And yeah, perhaps the rest of the speakers can talk about other barriers that they feel are the obstacles to making this mainstream or getting this actually standardized in your industry.
Sure, Cindy, I can share some of
yes, please go ahead. Yeah,
the work that I've done. I think there are two barriers that come to mind when it comes to facilitating circular economy, especially in developing Asia and DMC countries. One is that right now, most of the countries in developing Asia don't have a fee for, they lack a fee for disposing waste to the landfill, or the fee is very low. And so what happens is that because it's so cheap to just send waste to the landfill, all their options such as sorting and recycling waste and recovering the materials become uncompetitive, and in terms of the finances and such. So I think, and I think that in what we see is a lot of technologies from Europe or the United Kingdom. The reason they're able to have more recovery of waste is because the fee for disposing waste at the landfill is so high that companies do not want to send the waste to the landfill. They are, in a way, incentivized to recover as much as possible, so they don't pay that fee to dispose waste at the landfill. So I think that's a barrier in developing Asia. And one of the challenges with that is that who's going to pay for this fee? Is it going to be the consumers who are in developing Asia who right now don't pay these fees for disposing waste? Whether here in Thailand, I don't pay a fee right now to drop my waste off at the nearby dump station stuff. So there's no incentive for. I personally am incentivized to just not to recycle as much as possible, but for everyone else who's not informed, there's a lack of a push to not dispose that waste and such. So that's one issue. And then there's also extended producer responsibility, and that's something that's gone very well in Taiwan and in the European Union countries. But one of the challenges I've encountered through engagement with different stakeholders, that at least in developing Asian countries, large multinational companies, they do want to have an extended producer responsibility fee. They're happy to pay for it so that their wastes are managed. But what the issue is that they don't know in developing Asian countries, we don't always know what that fund that is gathered for disposing, handling the waste is actually used for. Is it used for other budgets within the countries, or is it actually being directly used to manage the waste streams that companies are paying for? So companies basically want to know, is there money that they're paying for this extended producer responsibility program, is it actually being used to improve waste management or not? So those are just kind of two challenges I see on my mind that are barriers to greater uptake of the circular economy.
Thanks, Pia. Really interesting as well. May I ask Joel then and you Tak to follow with in terms of scaling up and replication potential?
So I think I would categorize the challenges in 3 buckets. First would be the financial challenge, because when we are looking at some of these industries, these are small businesses and they are always constrained by the finances. So putting more money into the either acquiring a new equipment or looking for even utilizing the waste that they want to, so procuring that waste that can be utilized further for their processes instead of buying the virgin or a raw material. So this also requires a lot of collaterals or other investments. So based upon the constraint that we have, and right now when you're looking at some of these industries which are overcoming the pandemic, and there are other market barriers because the market has been very dynamic. So this completely, constrain the industries to put off a lot of money into, and there is a lot of risk that is associated, because they always need some precedence before that. Are they, when they are going to put up a money, whether they are going to be more successful with this or not. So I think the financial, and there are no specific schemes and the policies which can support some of these small businesses. So that becomes one of the major constraints, I would say, to begin with. And the third would be the technology. So a part of it being touched by, Pia also. Do we have a sufficient infrastructure available to pick up these from the very beginning of the industry, the logistics parts to it, picking up this waste, putting into the dump yard? Do we have a sufficient logistics behind it? So there is a huge gap in between, that there is a facility, it's somewhere available, and there is this industries who has the waste available, but where is the, some connecting dots that needs to be matched upon? So those matching is also a missing piece, of the availability of the infrastructure, the logistics behind it. So that's the another constraint, I would say. And the third, and the one of the major constraint, is the awareness. So are the people quite well aware about how to segregate these waste? Because the people who are working on the ground, the workforce, and the people who are directly working towards where the waste is being generated, or where the waste needs to be utilized, are they quite aware about how to utilize and how to segregate that waste? So the awareness about these new mechanism for the segregation, or new technologies, how they should be adopting. So that's, I think, are the three major constraints for the overall implementation of the circular economy. Yeah, I'll stop here. Thanks.
Yeah, and actually in battery industries, basically the global agreement to the 2050, we are get some carbon neutralization. And manufacturers, we are doing to reduction the carbon dioxide using to the RE-BACs, renewable generation 100%. And this is just beginning about to the manufacturing. And then we are doing to the some life cycle assessment to calculating whole life about the production, to using and go to the waste and go to the landfill and everything. But actually the carbon footprint assessment method, we are just starting in a couple of years before. So the manufacturers are still considering to the solution to reduction the manufacturing, during the manufacturing to reduction of carbon dioxide, and then how they can manage into the end of life batteries, and during the customer side and end of the waste side. So it is a kind of the we say to the battery passport. It will be operating in 2025 or 6 in Europeans, but in other countries you don't have any information or other database and records to operate manufacturing and selling and wasting. There are no information. So I think it is just the initial stage in Korea. Also, we are doing to how we can manage into the battery, all batteries to use the EV card and storage system and consumer and wasting. So I think the scale will be need to more time to the more investigation to the government or public side. So I think it is just the initial stage. Yeah.
Thanks, Yutak. So I'm hearing some, some similar barriers and issues arising from, getting this replicated and scaled up. So perhaps we could go to the audience for some questions before we wrap up with some of those thoughts. There is an interesting question from Miriam Arnell Azurin. She talks about how some countries support, incineration, waste incineration, while others don't, because it seems that, incineration actually could harm the environment instead of support the transition. And it needs a lot of ways to be able to burn for at least 20 years for it to be financially viable. So is your personal view, or is waste incineration part of circular economy? Anyone can take that question.
I'm happy to take that question.
Okay,
Cindy.
go ahead.
So in my own opinion, informed opinion, I do think waste to energy is part of the circular economy. You are recovering energy, but it's on the lowest tier. It's like the last option you should go for. And what we should be going for is trying to capture waste by segregating out the waste, trying to pull out the resource as much as possible, because really in the end, there will, in the circular economy, there's this, magic thing that, all waste will disappear. No, there will always be materials lost in the system, and there's got to be a way to deal with it. So we don't want that to be ending up in our oceans or in forested areas. And so if we can just reduce the amount of waste that we can capture as much waste into resource as possible and minimize the amount of waste that goes to waste energy incinerators, I think that's really what we should be doing. It's really about setting up the waste energy incinerator at the right size. You want, minimizing as much as possible and making it a small incinerator so that you don't incentivize putting more waste to the incinerator and stuff. So just in summary, it is part of the circular economy, but it's not the option you should go for at the start. It should be the last option possible. And for dealing with anything that cannot be captured back into the material flows system.
Thanks. Yeah, very interesting, because I know for the fact in the Philippines also do not support incineration. So we go to the next question. It talks about, innovative technologies having gestational periods and could not be funded through conventional financing schemes. So is there anyone here can answer thoughts on the type of financial solutions for a circular economy?
I can take that, a bit of that. I can try to answer some of the portions in this.
Mhm.
So, just when we look at especially the energy efficiency, given the return on investments are relatively have a short payback period when we look at the energy efficiency investments, and most of them are being funded themselves by the either the manufacturers or when they are looking at that. But when we look at the large investments and the circular economy, and given the overall the size, smaller the size of these, the larger the size of these investments are. So there are different innovative business models that needs to be put into the place. There has to be more incentives that we need to talk about. So although these, the new technologies or the innovations, always, because the manufacturers have the hesitance, as I also spoke about earlier, they are always risk on putting these investments, and due to the risk, the cost saving, they feel like they might not materialize, and the brand order of the volume may be decline, or sometimes they have the other challenges of like whether this investment will be passed on, and whether we will be able to get the more attractive interest rates or not. The banks are more supportive around that or not. And to enable those large, the flow of financing of these projects is critical to create an environment where the investors are presented of these projects and they have attractive risk return perspective, and then they understand the whole impact and perspective. There are different green solutions and green bonds there, and there are different kind of these investment tools now available in the market. It has to be channelized further to also loop into the overall understanding of the circular economy, because currently the focus that I see in India is largely on the like renewable energy, which is like just talking about one segment of it and then neglect the other part, like after the installation of these solar panels, who are going to take them back? So that whole has to be a sort of like an ecosystem and a channel around it. Like after this also, there has to be a full cycle of the investment that needs to come up, and then after the installation or after the cycle, after the life of these panels also, there has to be more channeling of the the investment that has to be more accompanying that. So yeah, that was my understanding on this.
Yeah, so it seems a lot more needs to be done to make these approaches pay for themselves in a way, make them the only thing to do rather than an option that is costly for some. We go to the next question. Perhaps this is for you, Tak, from Sokchia. By the way, the previous question was from Ashim Roy. So this question from Sokchia, Cambodia. What more economic benefits between electric vehicles and hydrogen? So he's probably asking the comparison between electric vehicle and hydrogen vehicle, fuel cell vehicle. Would you be able to answer that?
Yeah, this also to the clean vehicles, to electrical vehicle and hydrogen vehicles. But in current technical and economical comparison about to the both of the battery vehicle technology. So it may be around 90% of the countries, most of the countries using the electrical vehicle is 90%, and just 10% will be the use the hydrogen vehicles. That means to the electrical vehicle is almost commercializing in the every countries, but hydrogen vehicles is the just beginning stage of to use using the hydrogen vehicles, because it needs some more utility to charging to the hydrogen, and they need some mass production of hydrogen from the gas or other raw materials. So also the hydrogen fuel station is high technology to prevent the safety during the charging or storing to the hydrogen. So also the hydrogen vehicle is still expensive than to the electrical vehicles in every country. So I think in this stage to use the electric car is more comprehensive to using in the Cambodia. Yeah.
Thank you. Very interesting. I think the world really is moving towards more innovative technologies. I guess we're all going for net zero, and a lot of these approaches go into that. So it's not only about the environment or energy, but climate itself and climate mitigation. So this all goes towards the UN Sustainable Development Goals. And so we have the next question, or actually a comment from the previous question, talking about carbon capture and storage for incinerators and waste heat. I think this is an expensive distraction from low carbon and existing solutions. So it's even lower than the waste incineration in terms of the tier that Pia was talking about. CCS is just expensive, so it is not an option, I believe, at this stage. There's one other question. Okay, or this is a comment. They're saying that incinerators may be a good option to get rid of hard waste that cannot be recycled, like toxic hospital waste, dead animals, and things like that. I'm not sure whether everyone will agree that it is an option for that. Okay, Ashim Roy is asking, what is the prospect for waste to energy? I guess this is in relation to, again, maybe incineration.
Sure, I can
yes, go ahead.
I think waste energy across the world is similar to coal-fired power plants. Waste energy incinerators are going to be gradually decreasing across the world. The question now is, what's going to happen to the existing waste energy incinerators? Because there probably won't, I think it'll be very hard to build a waste energy incinerator in different countries. It'll have to go through a lot of environmental clearance and stuff, and it has to be set to the right size with the right amount of the best pollutant reduction technologies and stuff. So it'll be a lot harder to set these waste energy facilities up. But obviously, this depends on how strict the rules are in each of the different developing countries and such on how procurement works out. But I think the global trends, we're going to be moving away from waste energy. But in terms of the existing waste energy incinerators in America or Europe, whether those will survive without the financial support, I think that's something to be observed in the coming years.
Thanks, Bia. One last question, I guess this is for everybody. Are there any guidelines on industry sector recycling opportunities, meaning how much can be recycled, remanufactured, reused? Same participant asking, Ashim. So guidelines on, I guess, the circular economy for industry.
I can start, Cindy. So in the renewable energy industry, we see that it happens in various forms, and oftentimes it's driven by industry associations. For example, in the US, in the battery industry, the Energy Storage Association released knowledge products with best practices in terms of how to use batteries. And we see in Europe, they're way mature. They actually have a legal framework to establish end-of-life guidelines for batteries. In the solar industry, again, also driven by industry association in the US, they also released the Solar Energy Industry Association, or SEIA, released knowledge products and a PV recycling program, as I have mentioned before, to guide solar players within the US. So as you can see, it's quite industry specific and also location specific. We also talked to another industry association in Europe. There are no decommissioning guidelines per se, but they do plan on developing it. So it happens, there's a spectrum of where the guidelines are. Some are actually legally binding, some are quite loose, and they provide kind of guidance. So it happens in various forms.
Joel?
So I would say there are no specific guidelines per se as such for like how much waste should be utilized, but it totally depends upon the utilization, what kind of a waste are they looking at, and that will be defined by, if there is any limitations from the equipment. Let's say, I'll coming this as an example for a boiler. Like in case if they want to reuse some other waste, which is let's say a municipal solid waste into a boiler, or it's a co-firing system. So that completely depend upon if there is any limitations or on the boiler particularly. And there has been a lot of like these initiatives now coming up where the different plants are being set up. And I think it's still at a very innocent stage in India, where we are still looking at developing some of these guidelines and standards for the waste to energy systems and developing onto the circular economy. There are a few certificates which talk about the circular economy, but when it comes to the more deeper discussion, there are still some of these standards and the guidelines yet to be developed.
Thank you, and I'm sure they're forthcoming. You talk, please.
And actually, in Korea, we don't have any guideline about the circular economics, and we are doing to prevent the guidelines. But the battery manufacturers, Monica mentioned about, they are also selling their product into the US and European unions. So European unions, they are publishing to the battery directive in last year. So they mentioned about several things to manufacturers have to declare about the carbon dioxide generation, carbon footprint during the manufacturing until 2024. And 2026, they have to use the recycling materials to manufacturing new batteries. So these are kind of the guidelines. Also, they are also to the publishing to the a kind of the EPR. So manufacturing have to the responsibility to the making the everything to manufacturing and wasting management also. So maybe other countries will have to the following to that regulation or directives to kind of the guideline to the circular economies.
Thank you, Yuta. Hia?
I don't, I agree with Monica that it's really just depends on different types of industry, different types of products. I think one thing we haven't really discussed is just the design factors of these products. I look at e-waste and a lot of semiconductors. These products are designed not to be disassembled, and it's easy to collect all the. We actually have all the infrastructure. We have the data to collect all the different waste products, whether it's batteries, semiconductors, or cell phones. But the issue is that a lot of these materials, they are just they're molded in a way that you cannot disassemble them by mechanical process efficiently. Apple has a device that can disassemble iPhones very quickly, but obviously, Apple, there's other mobile phones out there. So I think something that needs to be taken seriously, just how do we design these products so that they're easy to disassemble, easy to recover and reuse in different ways, and maybe also finding creative uses for these products. I think it's very easy to kind of, as Monica mentioned, it's not just recycling, but there's also a reuse of the products or remanufacturing. And just the other day, I was looking at a situation in Denmark where they use an old wind turbine as a roofing structure for parking bicycles, and some use solar panels to power low power applications or just as a decorative table and such. So I think that finding industry standards is pretty hard, but we can get creative. I think there are ways if we can just make sure the waste isn't in the worst condition and we can safely recover them for more creative uses. I think that's something we could be considering.
Thanks so much, Pia. We are down to the last 4 minutes, and any parting words, maybe just a sentence from each one of you, and how you can promote circular economy before I wrap up. Nothing more? So it seems to me the common theme is that there is, the technologies are available, even new technologies are emerging to apply circular economy concepts. But it seems there are still some barriers, particularly in terms of costs, available financing, and knowledge, as well as awareness of industry or even participants to be able to adopt circular economy concepts and approaches or apply them in their industries. So, and it seems that what is still needed is some awareness and some collaboration. This is what is coming through from I guess, from the policy side, from the government side, from industry side, and also from the financing side, to be able to have these schemes that will enable these technologies to pay for themselves in a way that they are the only option, and they are no longer an option, but rather is the way to go. So it becomes standardized and mainstream. So thank you very much, everyone. I think we had a really, really good discussion and conversation, and I thank you all for your inputs and good questions also from the audience. So thank you, and we welcome you all to the rest of the sessions for ASEF, and hope to see you again soon. You take care.